I still haven't cleaned up the bench from the last tutorial about creating boat plots with a cheapo function generator and oscilloscope, card link. Anyway, each time I have that Fieldtech FY6800 function generator out, I remember I wanted to open it up and calibrate it. I mean, the most annoying part about that thing is that even if you set it to 0 offset, the outputs do have some offset. And yeah, so let's crack that thing open. And yeah, I've seen photos of some potentiometers in there. So let's calibrate this. There are 4 screws on the back side, and I'm just assuming these are the screws we are searching for. And from the feel, of course, self-tapping screws into the plastic. What else? Long ones. Okay, and I guess it will open now somehow. The clamshell, okay. So lift it up at the back, nothing's connected to the top, and slide the and slide it back a little. No? Yeah? Should come loose. Don't want to destroy the case. Maybe some snap-ins somewhere. Oh yeah, 2 snap-ins. So be careful when you open this up. There's not much in here, and I won't go into details because there are already enough detailed teardown videos of that thing on YouTube. So yeah, the back side, the front side just for orientation, the dreaded power board, yeah, at the front a board for the user interface stuff and the display, and what we are interested in, the digital signal generator board itself. And there we find here 1, 2, 3, 4, 5, 6 potentiometers. So a little bit closer for orientation again. Here's the back side, here is the front side, and there we have 1, 2 potentiometers left and right of this little chippy, then 1, 2 potentiometers here just behind that big heatsink, and then 1, 2 potentiometers here on the other side of the board, left and right of that little chippy. And we can safely assume that this side here, these 3 potentiometers are for channel 1, and the other side, yeah, you see it's basically symmetric. These 1, 2, 3 potentiometers for channel 2. The same again as drawing. Yeah, here's the front, here is that big heatsink, and we have the upper part is channel 1, 1, 2, 3 potentiometers, and the lower part is probably channel 2, 1, 2, 3 potentiometers. Now all we have to do is find out what potentiometer does what. And for that we have to connect the whole thing to power, of course. And starting with channel 1, I set channel 1 to square wave, 1 kilohertz and 10 volt amplitude, and I will connect my oscilloscope probe with a BNC connector to channel 1. Please keep in mind that when you connect that thing to mains AC is present inside here and about that area. Yeah, and there are exposed contacts, exposed leads from parts, and mains AC can cause serious injury or even death. So don't do that when you're not qualified to work with mains AC, okay? Now I will turn that first potentiometer here and we will watch on the oscilloscope what's happening. I'm turning down here and... oh, that's interesting. So our positive part of the square wave gets smaller or bigger. Let's turn our attention to that second potentiometer here, which I will turn now. And okay, that's clearly the amplitude. So, turning the third potentiometer. And that is quite obviously... oh, yeah. The DC offset, huh? I've already done the same for channel 2, analog to channel 1, which you saw. So, and here's the result. So, first potentiometer, channel 1, I call that the symmetry. Clockwise, it increases the amplitude of just the positive part of the signal. Counterclockwise, it decreases it. Second potentiometer, amplitude. Here, clockwise and counterclockwise is kind of swapped. So clockwise decreases the amplitude of the signal and counterclockwise increases it. Third one, offset. Here clockwise, counterclockwise works as expected. So clockwise turn increases the DC offset, counterclockwise turn decreases the DC offset. Channel 2, I'm just continuing. So the potentiometer to the middle, offset works exactly as for channel 1. Symmetry, yeah, and we are not completely symmetric on the board. I guess that part of the circuit, it's just copy-pasted down in the layout program. So second potentiometer, symmetry works as for channel 1. And third potentiometer, amplitude, also clockwise, counterclockwise, works the same as for channel 1. And now we can start calibrating the thing. Beginning with channel 1 and the DC offset, because if the DC offset is off, all bets are off. DC offset influences many things, so we need to get that down to 0. Fortunately, there is a waveform DC, which I simply set to, 0 volts. Yeah, most parameters are not even there, just the volts. And of course, I connect my probe to channel 1 again. And I'm turning here the channel 1 DC offset potentiometer. On the scope, I'm using the smallest possible vertical scale, and don't forget to have your probe DC coupled. And I have to admit, using that scope, I'm actually using 14-bit mode. Anyway, let's turn the pot now. We have to go up, so I'm turning clockwise until I'm in the middle on 0 volts. Wonderful. Now I can decrease the scale to, let's say, 10 millivolts and do some more adjustments to get it really centered. But yeah, I guess that is as good as it gets with these small trim potentiometers. I mean, my average voltage is now about -1 millivolt or so. Yeah, that's good enough. For adjusting the amplitude and the symmetry, I'm back to my square wave, 1 kilohertz, 10 volts peak to peak. And I'm turning the amplitude pot for channel 1 now. And remember, counterclockwise is increasing the amplitude. And while adjusting, I will really just look at the bottom here of my square wave, because the stop of my square wave we can adjust afterwards with the symmetry potentiometer. So yeah, 4 volts, lots of work to do. And going counterclockwise to get that exactly here at the 5 volt line. Now you can't see it, so I will change my vertical position. Just, let's say 5 volts. Yeah, 1 volt up. Okay. And now I should be able to fine-tune that. Yep, that looks good. And so my measurement here says I'm minimum at -5.05 volts. Good enough with a little potentiometer. And I couldn't be good enough, so I changed to 500 millivolts here. And yeah, I lifted my vertical position up even more, and now I will fine-tune to this line here. So yeah, this way you get a little bit, even if you don't have an 8-bit scope, you get a little bit more resolution out of it. And yeah, just correcting that a little bit further. Okay, now it's really vibrating. My pulse transferred via the screwdriver to the pot, influencing things. Okay, yeah, -5039. More than good enough. Finally, I'm turning the symmetry pot here. And full disclosure, I recalibrated the oscilloscope in between and started from the beginning, because I noticed some things were off when I changed the scale. I also calibrated the probe again, so but that doesn't change the procedure, okay? Just remember to calibrate your oscilloscope before you do that. In regards to the symmetry, we will look only at the top of our square wave. And again, I'm changing the position here and the scale. So I only have, the maximum resolution here for the top. So I'm now at 1 volt, and yeah, we need to increase that a wee bit. Clockwise increasing this time again. Yeah, that's on the mark. We can increase the scale a little bit further. Need to adjust my trigger again. So I come. Okay, 7 divisions down, and yeah, spot on. Okay, that's it. I will do now the same for channel 2. Now, you don't necessarily need an oscilloscope like that one to do the whole thing. You can also use a multimeter. simply, yeah, connect it up, and I'm here adjusting again the DC offset. So yeah, that works too. And is probably, well, not as much fun, but probably more precise. At least for the DC offset. When it comes to amplitude, yeah, you can also do some measurements here, but you have to keep in mind this is not an oscilloscope. So you should set your output to sine wave and something reasonably like 50 hertz. You can still, or you should still, be at 10 volts peak to peak. But remember, this is measuring RMS. So if you have 10 volts peak to peak, half that, 5 volts peak, divided by square root of 2, 1.41 for us people. And yeah, that's the value you should see here, which is, my calculator, yeah, tells me 3.535, and we are at 3.561. So yeah, the job I did with the oscilloscope for the amplitude was quite good. Where you run into trouble is looking at symmetry. If you want to look at symmetry with a multimeter, yeah, same thing applies for the settings here on your signal generator. So 50 hertz sine wave and 10 volts peak to peak. And your multimeter needs to be able to, yeah, display you the RMS value and the DC component, which should be near 0. And obviously we've done a good job with the oscilloscope here too. That's it. We calibrated that Fieldtech FY6800 signal generator, primarily using an oscilloscope. Of course, first we identified which potentiometer on the board does what. And I guess all these function generators, lookalikes and clones and different Fieldtech models will have similar inerts. We calibrated using an oscilloscope, and I showed you also how you could calibrate or at least verify your results with a good multimeter. Yeah, DC offset, the multimeter shines, of course, a little bit higher precision. Amplitude also, if you want to look into symmetry, it gets a little bit tricky. You need one that can display the AC value of the input and the DC component of that AC signal. Yeah, as I said, that's it. Until next time, bye.